Last part of Chapter P, Section 2, Exponents and Scientific Notation. A number that is in scientific notation is expressed as this. I'm sure you know and you're familiar with, especially from your science class, maybe your chemistry class, what a number in scientific notation looks like. You've probably also seen this in Algebra 1 and Algebra 2. A number in scientific notation is expressed as a number greater than or equal to greater than or equal to 1 and less than 10. Multiplied by some power of 10. So if I look here, this says which number below is in scientific notation. How about this number, 5,253,000? Or 5.253 times 10 to the power of 6. You got it. This is the one that's in scientific notation. It's a number greater than or equal to 1. Sorry, I missed the 2. Okay, a number greater than or equal to 1 and less than 10 multiplied by some power of 10. 5.253 is a number that is greater than, but not equal to, it's not equal to 1, but it is greater than, and it is less than 10. It's 5.253. So you can't have this some number times 10 to the power of something if it's a number that's bigger than 10. It's always got to be some number between 0, not 0, multiplied by some power of 10. So we're going to have like 1.2, something like that. Are the two numbers above here equivalent? And you say, yes, they are equivalent. If I take this decimal that's in scientific notation, it's 5.253, and this is multiplied by 10 to the power of 6. Well, positive 6 means move this decimal to the right to get this number in decimal form. I know it kind of seems silly to say decimal form versus scientific notation form when you see a decimal there. But really, this is decimal form, and this is scientific notation form. So I would take this decimal and I would slide it this many places, 6, to the right. And if I do that, I do get this big, large number. So my answer here is yes. To change a number from scientific notation to decimal form, you're going to use the exponent on the 10, just like I just got done saying. And you're going to move the decimal places, the indicated number of spaces, to the right if the exponent is positive. Okay, the exponent here was positive, and we said take the decimal and slide it that many places to the right to get the equivalent decimal form. And if you're out of spaces, what are you going to put in there? What are my placeholders? What values do I put in there? Yes, zeros. You're going to add zeros to fill in the missing spaces. And conversely, you're going to move the decimal places, the indicated number of spaces, to the left if the exponent is negative. So this is when you're converting. You've got to look at your exponent to know how many places to move it, and you have to look at the sign of the exponent to determine which way to move it. Here, exponent is positive, move to the right. Exponent is positive, move it to the right. Exponent is negative, move it to the left. Okay, 3.5 times 10 to the power of 5. So I'm going to take this 3 and this 5, and I know I'm going to have to move this decimal 5 places to the right. Well, I only got 1 space, so that means I need some placeholders. Well, how many more to get me to 5? 4. I need 4 zeros. And after I put my zeros in, then I'm going to go and put my commas in. This one here, 2.45 times 10 to the power of 8. I only got 2 places to move it. How many zeros do I need? 6 zeros. So I'm going to write down my 245, and I have to place 6 zeros behind it. And then I'm going to put my commas in. 245 million. This one here, 3.015 times 10 to the negative 4. Oops, oops, oops. I got to move to the left. I've got to move to the left, and I only have one space. So how many leading zeros do I need then? I got one space here, but I need 4. So I need 3 leading zeros. And then I'm going to copy all these significant figures here, 3015. I'm going to put the decimal here. And you really should put the 0 here, this leading 0, to indicate that this number is a number that's between 0 and 1. Any questions? Ringing a bell? Okay. To change a number from decimal form to scientific notation, you're going to reverse the procedure. Move the decimal to the right of the first non-zero digit. First non-zero digit. That's going to give me that greater than 1 but less than 10. First non-zero digit. The number of places the decimal moves is the exponent. Okay, so now we got to figure out what the exponent is. Here they gave us the exponent and asked us to turn it into decimal form. And now here we're going to put it in scientific notation. We have to figure out what the exponent is. The number of places that the decimal moves is the exponent. The exponent is positive if the given number is a number that's greater than 10. Look at this. This number is greater than 10, and the exponent there was positive. The exponent is negative if the given number is less than 1, but larger than 0. So some fraction in between 0 and 1. Look here. This 0.0003015, this is a number that's in between 0 and 1. And notice, the exponent in scientific notation is negative. So be cognizant of that. Write each number in scientific notation. Well, we know the decimal comes after the first non-zero digit. So I'm going to start out with a 3.2. I'm going to clip off those zeros. They're not significant digits. I don't need them. I'm going to multiply this by some power of 10. Notice this original number is a number bigger than 10, so the exponent has to be positive. And in fact, if I place it here, to get that big number back out, I'd have to move it 6 places to the right. 6,215,000. Again, I'm going to place the decimal after the first non-zero digit. 6 point. I need these digits, 215. I don't need the zeros, but I do need a power of 10. This number is a number way larger than 10. And so the exponent is going to be positive. And again, in fact, if I would place the decimal here, I'd have to slide it 6 places to the right to get that number back out. And so I've got 6.215 times 10 to the power of 6. Notice in part C, oh, this is a number that's between 0 and 1, so my exponent is going to be negative for sure. Well, my decimal is 5.2. 5.2 times 10 to some power. I know it's a negative power. Now, I'm going to go backwards. How many places to the left do I go? If I would put the decimal right here after the 5, I'd have to move it 1, 2, 3, 4, 5, 6 places. So that's to the negative 6 power. I'm sorry about the phone ringing. I'm guessing that the person doesn't know I'm recording a video. So get some practice with those. Wrap your head around it, which way that this is going to move, left or right. Because sometimes students, I don't know, they just mix it up. They never really just get it. So don't let that happen to you. Okay, side 2. Computations with scientific notation. The product and the quotient rules for exponents can be used to multiply or divide numbers that are expressed in scientific notation. Okay? The product and the quotient rules for exponents can be used to multiply or divide numbers that are expressed in scientific notation. That's why we had to do all the stuff with the properties of exponents. We're going to find the product of the following expressions. This is 2.4 times 10 to the power of 3, and this is 3 times 10 to the power of 5. Multiplication is commutative. You can move it around. I could think of this as 2.4 times 3 times 10 to the power of 3 times 10 to the power of 5. And 2.4 times 3 is 7.2. Same base, different exponent. What do we do with them? You add them. So this becomes times 10 to the power of 8. This is in scientific notation. I can convert this to decimal form. Slide the decimal 8 places to the right. I have one available place, which means I need 7 zeros after. So I'm going to write 7, 2, and 7 zeros. 2, 3, 4, 5, 6, 7. Put my commas in backwards. This is decimal form. Now you have to read the directions on a test or a quiz or homework to figure out how they want you to give the answer, whether it be in scientific notation or decimal form. The next one, again, I'm going to multiply the 4 with the 2 and these powers of 10 together. 4 times 2, of course, is 8. This is 10 to the power of 8 times 10 to the power of negative 11. I'm going to add the exponents, get times 10 to the power of negative 3. This is scientific notation. Decimal form is 0.008. The last. 6 times 7, 42. 10 to the power of 5 times 10 to the power of 14. Well, I'm going to add the exponents, and when I get to do that, this is times 10 to the power of negative 9. Now notice this number is not in scientific notation because the decimal does not come after the first non-zero digit. So you have to convert this. This number is really 4.2 times 10. I'm going to cover this up for now because I'm not going to consider this piece right now. I'm just converting 42 into 4.2 times 10 to the power of, well, remember 42 is a big number. So what are we going to multiply it by? It's a number bigger than 10, so the exponent has to be positive, right? 42 is really 4.2 times 10 to the power of 1. And then now I'm going to bring this down times 10 to the power of negative 9. And so now I have to put these together. Remember, same base, different exponent. You're going to add the exponents. So this becomes 4.2 times 10 to the power of negative 8. This scientific notation. Of course, when I convert it to decimal, I have to move it backwards 8 places. I've got one here, so I need 7 leading zeros after the decimal. I'm going to put that's my first 0. Now I need 7 zeros. 1, 2, 3, 4, 5, 6, 7, and then I need the 42. And this, of course, is my decimal form. Not too bad. Division is very similar. 4.6 divided by 2.3, again, you know, I can think of this as 4.6 divided by 2.3 times 10 to the power of 8 over 10 to the power of 6. 4.6 divided by 2.3 is exactly 2. I have a quotient. I'm going to subtract exponents. This is times 10 to the power of 2. This is scientific notation. Decimal form, well, I'd have to move the decimal, which is right after the 2 places to the right. So this is 200 in decimal form. I'm going to just write a D for decimal. Why don't you try this one? Pause the video and see what you could do. Okay, same thing. This would be 9 divided by 4.5. Well, 9 divided by 4.5 is 2 times, okay, like all I'm doing is that and then this. Well, I have to subtract the exponents. I can't leave this in the denominator now. This is scientific notation, so I have to bring this up. This would be 5 minus 12, which is negative 7 on that power of 10. This is proper scientific notation. And then, of course, decimal form, I would need 7 places left, but I've got one here, so I need 6 zeros. 1, 2, 3, 4, 5, 6 zeros. Don't forget, put your decimal there, and you need that leading 0. And my number is 2. So this is my decimal form. We need those 7 zeros. I mean, not 7 zeros. I need 6 zeros because this was my 7th space. I was looking at this one. Okay, One last thing, and then there'll be a homework assignment on the Schoology calendar. It'll also be an assignment in your folder for today. It's an application problem, so you have to read it. And sometimes you read application problems more than once to figure out what's going on. The mass of one hydrogen atom weighs this. Find the mass of 80,000 of them, and then express the answer in scientific notation. So I want my answer in scientific notation. Notice this is scientific notation, the mass of one. But this number right here, 80,000, that's not in scientific notation. So I know, since I want to express my answer in scientific notation, that I am going to convert this thing to scientific notation. Just going to make it easier for me. But the other question I have is, do I multiply these or do I divide them? Well, if one of these is this much, to figure out how many 80,000 are, I would have to multiply. And so I'm going to write this as 1.67 times 10 to the negative 24. And I'm going to say this 80,000 is 8 times 10 to the power of, now this is a big number, so my exponent's going to be positive, and I need 10 to the power of 4. So I'm going to write that here. This is 8 times 10 to the power of 4. Oops. Now I'm going to do 1.67 times 8. And 1.67 times 8, if you pick up a calculator, is 13.36. Powers of 10, same base, add the exponents. This is to the negative 20th power. 13.36 is a number bigger than 10. Remember, you had to be between that 1 and that 10. Less than the 10. Couldn't be at 10. And so I have to bust this apart. This part breaks down into 1.336 times 10 to the power of, remember this is a number larger than 10, so the exponent is positive. This is 10 to the power of 1. And then I bring down this 10 to the power of negative 20. And when I add these same base, I get 1.336 times 10 to the power of negative 19. My units are grams. Now, it is an application problem, and typically I make you or force you to write a sentence to give the answer, but not yet. When we get to the application problem section of the textbook, you'll be required to give the answer in terms of a full and complete sentence. Again, the textbook assignment will be on the Schoology calendar. It'll also be on your updates page. And that is going to end Chapter P, Section 2 for us. Have a great day.